It's a wonderful opportunity to be amongst fellow learners, both machine learners and human learners here. We have with us some incredible content for the rest of the day. I know many of you are here to take hands-on training sessions after this on retrieval augmented generative AI and generative AI, LLMs. Agus Sudjianto needs no special introduction. He's lot of all the models in some of the largest banks in the world. Almost every bank in the United States and the world follow some of the standards he's set for validation and also perceiving the value of models. Is a strong following globally on kind of building, designing models. He's also from the region. So last evening he showed me a brief excursion into the Padang cuisine, so locally. So he's an extraordinary fruit of the seeds growing around from this region. So please welcome with warm welcome to Agus.
Oh, thank you, Sri. Thank you for the opportunities. Coming to this region is always exciting. So when I was planning to visit my team in Hong Kong and in India, and then make a detour coming for a week in Indonesia to visit my mom. I was born and grew up in Indonesia. And Sri asked, okay, why don't we do H2O GenAI World in Singapore? Okay, and then I said, let's do it. I'll make a detour to Singapore, always having fun in Singapore because it's incredible scenery and incredible foods, right? This place is, if I look at foods, it's like the first thing when I arrived in Singapore, landed yesterday in the airport, I said, okay, the first thing I need to eat bak kut teh. Okay, so that was my first stop, and then okay, this is not enough. I need next to the bak kut teh stall in the airport was a young tofu place. Okay, I need to eat that one too. And then in the evening, Sri made a reservation going to a Michelin star restaurant. I said, Sri, we need to eat real food. So we need to really real food, not Michelin star restaurant food, right? So we went to a Padang store, right? We ate Padang food, right, in the Kandahar street. That was an incredible place.
Great experience, right? Sort of. I think talking about real food and real models, maybe it's a good hard detour. What is in the life of a bank, right? Sort of, there are a lot of models that are being used. Could you describe, set the landscape for this, what types of models?
Right. Decision making by model becoming more and more important. For us in the bank in the US, some of you may not be old enough to experience the crisis of 2008. The crisis of 2008, the big recession, the great recession they experienced in 2008 when sky was falling. The blame was pointed to model. At that time was the Gaussian copula was the blame. Let's see if and last year and this year as well, we have in the US it has a banking crisis. You experience it, right, Sri? So Silicon Valley Bank went belly up. Part of it they also get the blame on the asset liability management side of the model. So bank in bank a lot of critical stuff done by model, and AI play very critical role and a lot more important role. From credit decisioning, from fraud detection, from listening to customer when customer complain and how the complaint are being handled. I'll give you an example why the complaint is so important. In the US, it has regulation. If you're not happy with your bank, you have problem, anything, you call the bank, right? Or you write email to the bank. That complaint has to be resolved by 10 days per regulation. If it's not resolved by 10 days, bank can get fine and penalty. Right, so it's a big deal, and a company like Wells Fargo, when you have a lot of customer, you have 1.5 million complaint per month. Okay, 1.5 million complaint per month. Every one of them have to be solved in 10 days. How would you do it? So you hire army of people. These people are relatively in the low-paid job and a bit boring, looking, reading, and routing to the right people. So it's very difficult. You have very high turnover. You have to train all the time. So that's when language model come to the rescue. Now language model do the job. By the way, because you have to hire people, train all the time, their accuracy of routing is only about 60-something%. If you route it wrongly, you will not solve it in 10 days. Right? Because wrong routing, go somebody else. Okay? So language model has accuracy of 80+% accuracy. So huge difference. You don't have to retrain people. And this one becoming more and more coming.
So the heart of language models is this incredible paper that came in 2017. Many of you remember, attention is all you need. So now it's working remarkably well. Most of us are seeing the fruits of it, and we have some idea of why it works, and some of it which we don't know why it doesn't work. For example, for reasoning and others. What is your intuition?
Intuition on this one. All of you familiar with neural networks, right? I'm assuming. Yeah, all of you familiar. And ReLU using ReLU activation function. A few years back, I wrote a paper on how to unwrap ReLU neural network. What is it really? What ReLU neural network do? ReLU neural network is really local linear model. If the ReLU unit is turned on, it's linear. If its things is off, it's zero, right? A combination of a lot of ReLU, combination of linear, still linear. So ReLU network creating locally linear model. If you have, basically is A1x1 plus A2x2 plus A3x3 and so on and so forth. So local linear model like that is what you can check that paper, and then H2O implemented in H2O wave, the Alasia, right?
Where is Shivam?
Where is Shivam? Shivam is the author of that. Put how you unwrap the ReLU neural network, so you know exactly all the local linear model. How many local linear model inside the ReLU that you train?
We should also credit agent on.
Yeah, and the team, my team. So Shivam worked with my team that in Hong Kong that do this. So local linear model. What attention? If you look at attention, this is the really important. And many of you that follow Kaggle, we have several Kaggle grandmaster in the traditional machine learning. In tabular data, gradient boosting machine is always win. Neural network is a laggard. Okay, in this. But why is this? Okay, a neural network is locally linear. To get interaction, what we call it interaction in statistics, x1 times x2. It's difficult representation in ReLU. You have to cut it into small region, and each of them will be approximated with linear model, because interaction is very difficult for neural network. Okay, now gradient boosting machine, like tree on the other hand, is very interaction. I split it with x1, and then I split it with x2, and then I split it with x3. So interaction is captured very fast by tree. So gradient boosting machine in tabular data beat ReLU network all the time. Now, here's the beauty of attention. Attention, if you remember the basic attention, it has K, Q, V, basically x time another x. So the interaction term is captured by attention, something that is missing. Now you have feature representation as interaction. x1 times x2, x3, that's captured by attention because that's a structure. And this is very important in language, because language is about context. Word and word. And the context is not consecutive. In convolution, it has to be consecutive, it has to be neighborhood. Attention, you can jump, right? So interaction with any, this word here has context with 10 words later in the sentence, right? So that's why attention works so well, because it captures interaction across variables, something that is missing in the standard ReLU network. It's really the feature engineering layer. Once you have the right feature, then you feed it to ReLU. That's why if you look at all the transformer, it has layer of attention to create high interaction. And then after that, you feed it to ReLU network to do work. The feature of that go to ReLU network. So that's why attention really important, and a breakthrough on this is missing link in the traditional ReLU network.
Brilliant. Embeddings.
Yes.
I want to touch on, so attention is all you need, but there's a contrary or even almost a complementary concept on embeddings, and what some of our professors like Boyd would probably say embeddings is all you need.
Embedding is very interesting concept. If some of you familiar with traditional tabular data, you have variable, you transform it. You transform it into using log transformation or quadratic transformation. That's embedding, right? You embed it into that. Then you create you do feature engineering. You create x1 times x2. So you embed it in higher dimension. You embed it. You create features. Now, all supervised machine learning, including GPT, right? Because it's trained with a certain target. If you look at neural network, the final layer of neural network is linear model. The key is the last layer is very good embedding. You transform your input into higher dimension, better domain, so that linear model, the last layer, work very, very well. If you look at gradient boosting machine, it built into 3 nodes, individual nodes of the tree. And the model is actually linear model of that terminal node. That's why if you go to XGBoost, you can go to XGBoost table, you can see the coefficient of each node, coefficient regression of each node. So all of this machine learning, what it does is transforming from original variable into an embedding space, so that linear model work the best. So embedding is very, very key. Now, with your language model, it's the same thing, right? All the language model, if you look at it, it's transformed into integer, and then go through all the attention layer for embedding, and then go to ReLU layer for another embedding, and finally it's a linear model to do decision. So it's so important because embedding is the feature engineering. In the old days, we do feature engineering by hand thinking and all this thing, how to do feature engineering. Now with all this machinery, embedding is the feature space. It's the feature engineering. It's the key in machine learning, so that finally linear model will work best. Just like in neural network, final layer is linear model. In gradient boosting, it's the same thing. You create it and then embed it in the 0-1. Is the difference is in gradient boosting, the embedding is one-hot encoding, 0-1, 0-1, 0-1, whether the data fall into that. In neural network, the embedding is locally linear model.
Amazing. Goes back to the theme we started with, the interactions of so many different cultures in Singapore actually makes it a very unique place, right? All the different interactions. And obviously for embeddings, if you're looking at Arabic or different languages, you need different embeddings. For LLMs, language makes a big difference. Where do you see the space moving? Especially there's so many different languages to cover.
Right, yes. Embedding, if you think about it, embedding is a representation of the world. How you see the network, the model, take the embedding and then make decision of that. Even what you're going to spend this afternoon in RACs, it's like you have the embedding model, which translate from whatever domain into that domain, right? So it's very, very important. The quality of embedding is very, very important. All this LLM, all this RAC application that you're going to build, the key is to get really, really good embedding. How to really get the good embedding is the architecture of your model, which is nowadays very standard because it's transformer. So now the other part of that is the data. So the data is very important to get the real embedding, because embedding really how you capture knowledge. And this is just like human being. Everybody learn differently. So they capture the knowledge representation in the brain very differently. So just like large language model, we have so many of them. One will be better for another because the embedding, the capture the knowledge differently through embedding. When you want to choose about which one to use as your embedding, as your LLM, because nowadays you have so many open source, which is wonderful. It's like how you choose your team. Okay, like choosing your team member, hiring people, the thinking, the approach, the knowledge that they have, because they say, okay, what kind of things that you need. So choosing LLM is like choosing team that you're going to recruit, right? Which one? That's why in Arabic language and all those things, you need to have a specialized embedding.
It's a culture of LLMs, right?
Cultural.
Armin Society of Minds, there was the Armin Minsky many years ago, right? So going back to choosing your team, it's a very interesting topic. I'm sure you get asked every time, I'm starting a new place, new bank, new fintech, I need to build a whole, or even entertainment, media, they're going to start a whole data science team and build. What is the kind of secret sauce? How many Kaggle? So the Kaggle Grandmasters are good at competitions. Then you have deep industry domain expertise. You have the industrial data scientists, and then you have the professors from the university. You happen to have
all of them.
A good chunk of all of them. So I mean, with Vijay and his team and whatnot. So maybe it's a good to give the audience an idea of how to build a team.
I share with you a little bit. If talking about team, in Wells Fargo we have several thousand of model that we manage to run every aspect of the bank, and we have somewhat large team. We have 1,500 people, data scientists in our team, 1,000 of them in the U.S., about 500 of them in India. And people, for institution like us, we have we recruit about 100 people out of college every year, right? So, and we train them because of we have the resource to do that. But most of you probably don't. So then, how would you do it? So when we look at this, there are a few things, right? When we do data science and all of this, it's really people we need to put together people with various talents, different background, and to be able to find a unicorn, somebody that can do everything, is hard. So we have to find people that good in certain thing, may not be good in other thing. From business knowledge, because at the end of the day, in data science and AI, we build business solution. That's at the end of the day, what's in it, what the business will get out of it. So the business knowledge is important, and that's a very specific domain. And then you need to have good data scientists, people that can work on this. And of course, you also need machine learning engineer, because you need to put this into production. So thinking about people that can put this thing into production, people that can build model, that people can understand business. So different scale that you have, different company. In a smaller company, you have to do everything by yourself. Some of you probably do that, right? I have to do everything myself. I cannot ask anybody. In large company, like in my world, they are very, very specialized. People that dealing with data, that's not part of the 1,500 that build model. 1,500 people build model and maintain model. That's different. And then we have technology partner who really operationalize build infrastructure. So it really different kind of thing, but need to think about how to put all of this knowledge together. And depending on the scale of the company and what you do, you probably have to recruit people that can do them all. May not be very expert deep in certain area, but can do them all. And if you are a bigger company, want to be specialized, then build people with deep knowledge, very specialized.
So on the LLMs, how are you validating these LLMs differently than regular machine learning models?
Thank you for the question. I'll give you a little bit background on this in the US, especially in the financial institution. In the US, in financial institution, it has called SR 11.7. SR 11.7 is basically how to manage model risk. Every model are wrong. This is the thing that's very important for people who build model. Be very humble, right? Because all this model will be wrong, and it can be wrong, and when they're wrong, they can create harm either to the company or to the people that subjected to the user. So we are always very, very humble in terms of model, and we need to really understand how the model will be wrong. So that is really the area of model validation. How can we test model rigorously to understand where the model is weak? So that's model validation. And model validation, in principle, we really just like people that do information security. You want to hack this model. You want to find the vulnerability of model. How, in what situation, in what condition model will be wrong, right? And in tabular data, you can do that very easily. And some of you that want to see some example, my team released a tool called PyML, Python Interpretable Machine Learning, and you can download and use it. In fact, today they released the 0.6 release that's fully compatible with H2O. Every H2O model can be tested, can be validated with PyML. And so looking at few things, model weakness, which area that the model will be more wrong. If you look at AUC, you look at mean square error, it's not only just single number, but in what situation that the AUC will be bad, right? So model weakness identification. You look at model robustness. If the input has noise different, is the model still going to perform? You look at resilience. Under different situation, is the model going to still work fine? That's resilience. And then we talk about reliability. How reliable is the output? How certain is the output, the decision? So that's in tabular data, we do that. Now in LLM, one of the key important on this, all of this is really explanation, try to understand what the model does. That's where all the XAI, explainable AI, try to explain what the model do. Now in LLM, it's a little bit more challenging because you have a big black box, right? Explainability is a little bit more difficult to do. Now, explainability, if we talk about the embedding, it's really understanding how good is the embedding. In what topics the embedding is done well, in what topics not done well. So you start from that embedding quality. You have to see how the embedding quality. And then you look at all the principles that we talk about, model weakness and identification, and all of those things has to be done. For example, if you do for RAG, which is going to do a lot this afternoon, right? Retrieval augmented generation. It has information retrieval side, to establish the context. That you need to do precision recall, and you need to identify in what condition precision recall is not good. Beyond just single measure of which you're going to learn probably this afternoon. And then you also have to do robustness. How robust? Because in LLM, the difficult piece is a lot of data coming in when you train it. When you test it, how do you know that this testing data is not part of the training? In tabular data, you can do it. You can test it. You can see it. But if you have pre-trained model, like in LLM, you don't know. So it might be this testing data is actually not fair because it's already in training data. So that's the difficulty, right? So you have to be more creative. How to do it, how to make sure that the testing data is not in the training data. Then you do something like negation test. If you negate it, is the answer is still correct. You do invariance test. If I alter it, if I shuffle the word, is it going to still working? If I change it into synonym, is it going to still working? And you do directionality test. If I make it becoming more, is it going to be more? So a lot of testing that you have to do to make sure that the model will generalize well when you put it in production.
So the conceptual soundness of an LLM is a new territory.
Yes, the model conceptual soundness, how sound this model is really how sound or how good the embedding is.
Small number of large models or large number of small models?
So three question is do we want one model with 100 billion parameter, or 100 model with 1 billion parameter each you use, right? Sri? Yeah. So I think this is going to be a still continuous debate. But if my it really depends in my understanding. In real world, we don't build model for general purpose, like ChatGPT or GPT-4. They try to build foundation model for large general purpose. It can do math, it can do medical question, it can do all of those. So it becomes generalist, jack of all trade, master of none. Right? So just like people, somebody will be.
But you showed me a paper yesterday where basically the GPT-4 is beating the medical specialized med plan to the models.
Yeah.
Just keep,
I think it really depends. In my opinion, let me go back a little bit and then I'll answer that then. So, and then when you also do testing, this is the problem with LLM testing today. People make a claim, oh, this one better than the other, this one better than the other, one better than the other. I don't believe any of those. The reason is better one than the other based on your testing data, how you test it. And the testing data, you can always craft it in a way that this will be better than the other. Right? So it's really testing data dependent to make that claim. At the end of the day, it has to be your own problem. With your own problem, you test it, whether this is good or not. Because even testing that, I commend all those thing people that try to do, Helm, data set that Stanford put, right? It's try to test it for all kind of capability. Oh, it's nice. But for real application, is that the test that you want to do? No, because it's specific domain, your own data. So all of those is good to know, but it's meaningless. So we have to test it with your own things. Now, if it's really small subject, narrow application that you do, you're not trying to use your model to be able to answer a gymnastic question or swimming question, then you don't need the big model. You need very small specialized model. That's all you need. Specialized model that you do. And even if you do RAG, which you're going to learn a lot today, retrieval augmented generation, the data is your own data, right? Your document. So retrieve that document. So you need small embedding for embedding model. You don't need big model for that. And then you retrieve the information. Once you retrieve the information, you send it to large language model to do summarization. Right? You get this data from your own document, retrieve from your document, and then you summarize it. You only need, depending on the language that you want to use, you only use large language model to do English, to summarize from the knowledge of this. If you just try to do writing English better, I think anything bigger than 3 billion, you don't will do a decent job. A 7 billion parameter model like Llama 7 billion will do a very, very decent job. You don't really need 100 billion parameter model. So that's from practicality reason.
We like the Mistral 7B. It has a very good attention mechanism,
right?
Overlapping windows, so it gives a very reasonably long context as well. So 7B has been doing really well for us, open source Mistral.
Yes.
But I think there is a thought that even the largest models are actually a combination ensemble of 20 billion or 30 billion models. So
I think this is what we learn as well from the traditional machine learning, right? If we have a few Kaggle grandmaster in the room, the winner typically is really model stacking, right? You stack multiple model, different model, you stack, you average them, you're going to be the winner. You stack multiple model. Each model do different thing. They all relatively accurate, but they are different model. They work very well. So I think as this field mature, I think my hunch, we're going to be the same thing. Small model, you're going to have mixture of expert. I heard that actually GPT-4 is a mixture of expert too. It's not a large model, but combination of a small model created a mixture of expert, which is model stacking. work very well. So that's when come back to the 100. You probably need a certain threshold so that the English context or whatever language context can be captured well. Probably 3 billion parameter model. We have 100 of them. Probably better than 300 billion parameter model.
Probably one of the last of the few questions. Retrieval augmented we talked about. By the way, Eval Studio, shout out for that. You'll see it's a very powerful way to kind of evaluate your models continuously. Today we'll probably train you on some of the evaluations that you can use Eval GPT or Eval Studios. One of the things that, Agus' voice is so well respected by the SEC, by the regulators and others in the US, that sometimes some of the models we want to build are going to try to mimic your accent. So that here it's very natural accent, right? It's not so natural in the US. So in fact, kind of at that bend of the Indonesian English, Southeast Asian English models. When do you fine-tune models and when do you want to use RAG?
Well, I would say the first approach should be if RAG can do the job, do RAG, right? Because that's the easiest way to do, right? And use you don't have to train model. So if you can use RAG, that will be the first option. But sometime in a specific domain, it has very difficult differentiation in terms of certain domain. Like we use our large language model for model documentation, for documenting model validation. So the context is very specific, and if we use language model that is not trained specifically, it's difficult to find a small nuance, the difference in small nuance. So if you have problem that small nuance make big difference in terms of decision, then you have to train specifically fine tune your model. But if not, then I would start with RAG, because that's a lot of tool out there. The H2O has this tool that's turnkey, right? Easy to use on the RAG. So and most industry application today is all RAG today in banking, in the big banking, and all those things.
What kind of use cases? Maybe you can touch a little on the use case.
Yeah. It's a use case in a bank. We all have myriad of million document finding information. For example, I give a few example. Finding what rule, what regulation are applicable in certain jurisdiction. For us in the US, where every state have different regulation, there's all kind of different regulator as well, finding, okay, what is applicable in my area. So we have a lot of policy, 1,000 policies. So it used to be a lot of Q&A, very difficult to find information. Now it's very easy to find. You ask question, you have Q&A, people can get the information. We use it to help customer have question. Remember the person that do customer service, they are not really the very well paid, so you have high turnover. So you have language model that can help do RAG information retrieval to help that. You do sales pitch or making some kind of pitch to your clients on the commercial bank side. So it's very helpful to do something like that. And so myriad application that you can do, because we are finding information in the company is very difficult. And the best way to do this is really that's the RAG application.
Probably the final question for regulating AI. There's a lot of AI doomers. We are AI tech optimistic on the extreme side. H2O, we think that the world needs so much help that AI can be a force for good. What are the perspectives you're hearing?
The problem with all this regulation are really a lot of self-interests of various groups try to lobby. That's in my view. I hope the US will go to the they will correct it, go to the right side. And if you go to the lobby, you're going to create rules. It's a lot of lobbyists. And lobbyists here are paid by somebody. And who has the money to pay? Are really the big corporations that have a lot of interest to protect themselves. So I hope the regulation will not pick a winner, that Microsoft will be the winner, Google will be the winner, and the rest are the loser, especially the open source, because the open source doesn't have a lobbyist. That's the biggest worry that I have. That will be a terrible thing. In my opinion, AI, algorithms, large language model, it should not be regulated. What should be regulated is the layer of application. You apply it for certain purpose. That need to be regulated, because that's where the danger is. So at the application layer need to be regulated. The large language model itself should not be regulated. That's my view. Because the damage, the harm to the society, the misinformation or whatever things are the application layer. That need to be regulated.
Well, AI is math, right? Math has been handed to us for generations, centuries of innovation, and math has incredible transformative power, and I think it needs to be in the hands of the people. For us, open source, you mentioned interestingly, we don't use the word lobbyist, but the real love for open source comes from the community. We did not announce this event longer than a couple of weeks, but look at the audience, they're all here. And it's a global movement of open source enthusiasts, makers, creators, doers. They are voting with their hearts and minds and using the platforms.
Right.
So I think open source has the people on its side.
Yeah.
So,
yeah.
I think that's kind of the what we have experienced with our own journey at H2O. So we are super strongest believers in and supporters of open source. So the models come in the hands of organizations and the people. Every purpose needs a large language model.
Yeah.
And if it's a good purpose, it will get enough audience and enough momentum. And the world is an oyster to change at this point. So AI is an incredible time frame to be in AI. So welcome to H2O GenAI World.
That's just an incredible, I think very exciting. I want to do last word here, Sri Maime, because it's very exciting time for you. I was born 25 years too early in this world. When I have my PhD in machine learning and neural network was 1995. So when I graduated my PhD in machine learning, I cannot find a job in machine learning. So I have to design a real machine, right, Sri? So I designed car engine for Ford Motor Company because no such job of machine learning. So I felt like I was born 25 years too early, and now my daughter studied at Carnegie Mellon studying AI. So, man, what a wonderful world for many of you to be at this time. So I think you should cherish it. I want to say one thing. Building AI model becoming a lot more easier and become very easy today. Testing this model is not easy. So you need to pay attention on the testing, not only on the building. And then when you do testing, be humble and be honest, because if not, it will bite you. So I think it's the skill of to be able to test, not only to build model, building application is super important.
What an inspiring journey. From the beginnings here in Yogyakarta to all the way till everywhere in the world. In terms of parting words for the audience, where do they go from here?
I spoke about this. It's an exciting time. Build model, but build it in a very responsible way. Thinking about what potential harm that this model can do, because this model can become very discriminatory to people. to people with different socioeconomic level and all of these things. So don't build model, don't be evil. To use this model, don't be evil. And it's very, very important thing about will your grandma approve this? You build an application like this. Super important.
Fabulous. I know there's a room full of questions and interactions that are waiting to happen. Agus will be here sometime before lunch, for sure. Definitely meet him and get inspired like we do. We're really fortunate to have the likes of Agus on the side of the open source community.
Thank you. I think it's, having a big audience with the technical background is always entertaining for me. Always very energizing because I thought my job is doing management entertainment. I get paid to do management entertainment, talk to senior management all the time. So dealing with technical people is always my excitement because I still write paper and write code, right? So thank you so much.
Thank you.